Good evening, everyone. We hope you're keeping safe in these difficult times. Thanks for joining us for this interesting webinar on Neo4j. This is Sashi, your moderator for the webinar. For those of you who are kind of joining our webinars for the first time, at StarOf, we are a tech-driven startup. We seek to match candidates with work more efficiently. So we are striving to create a marketplace, a vibrant marketplace where people find exciting career opportunities, and also companies find great candidates to join their teams. So that's what we do at StarOf, and then we conduct these webinars to sort of engage the community of people who work with the company, who work with us. So we're joined today by a very special speaker, Jennifer Reif. Jennifer is the Developer Relations Engineer at Neo4j. She's a widely followed conference speaker, a blogger, an avid developer, and a problem solver. She has worked with large enterprises to organize and to help them organize and make sense of widespread data assets. And Jennifer loves learning new technologies and launching new products. In her job, she is responsible for building a strong community of developers or Neo4j database developers around the world. She lives in California, and she loves classical music and horses, quite interestingly. She's active on social media. Her Twitter handle, JMH Reif, is very popular. You could follow her on Twitter to get updates on Neo4j and also a lot of other technical stuff. She also has a website, jmhreif.com, where she talks about the new releases and Neo4j and all the new functionality that's coming up as part of the future releases. Jennifer, welcome to the webinar. We're so privileged to have you join us today.
Thank you for having me. I'm super excited. So,
yeah, a quick introduction to the topic at hand. We sort of live in a connected world, and it is only ideal that the information that we store about what we do, all the transactions and everything, in a manner that focuses on the relationships between data. But most of us are used to programming with relational databases, which focus on just storing the data, and the relations are like an afterthought. They are functional, no doubt about it, which accounts for the fact that they're still popular with developers, but they're very, very limited in their ability to help people parse the power of connections and deliver intelligence that is rich in context at the scale at which the modern world demands, given all the data that we generate, the huge amounts of data that we generate every day. So this is the problem that Neo4j set out to address a decade ago. And it was built to efficiently store, handle, and query highly connected data in your data model. And with a graph database like Neo4j, you can represent real-world information, whether it is coming from an application or if it's something that you have like a platform. So you could actually focus on the relationships in your data, without really having to spend a lot of time writing complex queries. But having said all that, developers, especially those who are kind of used to programming with the relational databases, find it very, very hard to sort of transition to a graph database, because it is so new, right? So we are so used to thinking of data as being records in a table, that a graph database with its focus on relationships is really, really counterintuitive to most developers. So we thought in that context, a session on graph databases with a focus on Neo4j, which by the way is the most popular graph database out there, would be very, very valuable to the developer community. So here we have very interesting session on the cards. So session will be for 15 minutes, and we have 10 minutes at the end set aside for Q&A. So any questions that you have, feel free to use the chat to ask those questions, and we will compile them and then have Jennifer answer them at the end for you. So with that, I turn it over to Jennifer. Jennifer, over to you.
Okay. Let me share my screen here. Get that all set up, and I will keep an eye make sure everybody can see that. So let's start rolling. Thank you so much for the nice introduction there. I won't have to do a whole lot of introduction for myself then. But we're going to talk Neo4j from a developer perspective. I'm going to try to cover all of the basics of Neo4j. Yes, all of them, but at a very basic level. And then I'll kind of dive in and share just a little bit of tidbits on Java specifically or programming with Neo4j. And then maybe another session down the road or more content that I'll send some resources to if you're more interested in kind of the Java specific stuff. There just wasn't enough time to cover it all today. So I already got a good kind of introduction here. There's a lot of things that I enjoy doing, whether it's technical stuff or not. And basically a lot of it just boils down to I'm kind of a geek. So I had a whole long list of hobbies and things I enjoyed, but they all kind of just boil down to I'm a geek. So my contact information is there in the lower left-hand side. It will also be on the last couple of slides as well. So don't panic if you don't get that stuff jotted down or screenshotted. There will be another opportunity for that. And I'm always happy to answer questions or continue discussions on technical stuff later down the road. If you think of things, I know sometimes questions or concerns pop up after a live session like this. So feel free to reach out. Okay. So let's dive right in. Let's say we have an existing problem. Maybe we want to know what changes have been made in the latest Java developer kit to the java.time package. Other scenarios we might want to know, what's the current supported JDK? How many versions might our current project be behind? So what would be the upgrade steps basically? What impacts does a change have on my code base? So basically if they make a change in the JDK to something particular for the next version, how does that impact my project? Or what does an upgrade from like Java 16 to 17 look like? What is that all going to entail? And these things are really hard to answer in existing solutions. So you're dealing with thousands, maybe millions of dependencies and nested hierarchies in your software projects, as well as just in the JDK changes themselves. So if you're looking at a relational database, the great thing about those is they're great for reports, simple joins, all that sort of stuff. But when you talk about these nested joins and kind of going several levels deep for a variable length kind of nesting structure, that gets really complicated really fast. Document databases, so something like MongoDB, the good thing about that is they're great for pulling individual components, and they also automatically include or can include some nested substructures, subdocument structures, which is super nice to pull kind of related or child components. However, the con with that is if you get a lot of substructures going at once, you're still pulling more data than really what you need, or you potentially have a lot of those joins again to go across documents and kind of aggregate those documents together to piece them into a picture that's meaningful and valuable. So again, kind of bringing that necessary data all together can get super complex very quickly. Key value store, great for just kind of bits and snippets of information. But again, when you talk about aggregating related data, that gets really complicated really fast. So the existing solutions just really don't provide kind of an easy and performant way to do this sort of query or to answer this sort of problem. So, okay, I've heard about this graph thing, how would that help us out? Is this going to even be an option? So just a very formal definition up front here. A graph is a set of discrete objects, each of which has some set of relationships with other objects. So don't worry about if that doesn't make sense. We'll kind of go and walk through that and explain it in kind of easier to understand terms. But this initial problem was formulated with the 7 bridges of Königsberg by Leonhard Euler back in the 1700s. So graph theory has actually been around that long. But he was trying to figure out there were 4 land masses and 7 bridges that connected them in the city of Königsberg, Prussia. Was Prussia at the time. And so he was trying to figure out if he could start from a certain point, cross all the bridges, touch each of the land masses, and come back to his starting point. And so Of course, you see kind of that picture of it on the left-hand side. You see the actual map of it there in the middle of the graphic. And then on the right-hand side, you see the actual graph structure of it. So you have these entities, your land masses are the blue nodes there. And then the bridges that connect them are the relationships between them. And actually, the problem that he was trying to solve, the 7 bridges of Königsberg problem, is not solvable. However, the work that he did and the research and the theory that he put behind this became the foundation for graph theory, which kind of also then became a foundation for graph technologies, graph databases specifically. So what does graph have to offer me? This, might be something I need to look more into it. Really, what graph brings to the table is it truly shows how data is connected in the real world. So we have our example image here. We have our blue nodes there that are people. And then we have our kind of red, orangish nodes that are companies. And then our green nodes are technologies. And we can start to understand more about maybe a person's network or a company's surroundings and involvements based on the relationships that are in the database. So for instance, Jennifer there, you can see I have several friends relationships. There's one particular or a couple different technologies I like there. I work for a particular company, but then you can go multiple steps out from that and say, okay, who's she connected to? And what are they connected to in return? And you kind of get this kind of sense of a community and understanding of the community that forms around a particular person or even just a set of data. So a database, whether you're dealing with graphs or any other type of database, they're all going to kind of do the same core thing, which is kind of that first definition there, a structured set of data held in a computer, especially one that is accessible in various ways. That's what a database is at the very, very base level. So whether you're dealing with relational, NoSQL, graph, any of the others, they're all going to do that basic thing. However, what a graph database does differently is that it uses graph structures for semantic queries with nodes, edges, and properties to represent and store the data. So basically, we store the data a little differently. That allows us to query the data a little differently, and you're going to get kind of a different, not necessarily result set, but a different kind of outcome on the other side based on the way you're storing and querying the data. And we're going to actually look at that. So what can graph do for me? Are there other places where it's being used? What is really good about it? And this is actually something, this was something that's not currently in the Wikipedia article for the graph database article on Wikipedia. But I pulled this and I really liked it, so I'm keeping it. So you probably could go back through the history of the Wikipedia article and find it again. But I've retained it for this slide. So basically what a graph is going to give you, I've highlighted kind of the pieces that I want to focus on here, is the graph allows you to retrieve and focus on a piece of the graph. So you're not pulling the entire database. You're not pulling massive swaths of data that you don't care about. You're not pulling things that are irrelevant to what you're looking for. It's only searching for the things that you're asking in the query, basically. Which means that performance then is proportional to the size of the data that you need to traverse, not necessarily the size of the data store. If you've ever dealt with, kind of large, tables or even other database sizes and things like that, that as your data grows, the less and less performant some of your queries might become. This then, because of this statement here, because of the way graph works, you're only traversing through whatever piece of the graph that you need to traverse, which means that no matter how much your data is growing around it, you're still only traversing this tiny little piece of the graph, which means your performance is going to stay consistent. So that's kind of really the highlight of graphs in general. So looking at the structures of kind of some different databases compared to graph, we'll first take relational. So let's say we have employees and we want to find out which departments they work for. So in this case, we go to our employees table, we look up the employee that we're concerned about. And then we'll probably have a lookup table, associative entity join table, something like that in the middle that is basically going to keep all of our data normalized and clean, so you don't have a duplication and stuff. And then it will go look up Alice's value in this case and say which rows she falls on in that join table, and then go over to the departments table and grab the lookup values for the departments that we got in that middle table and look up the kind of valuable meanings for those departments. So in this case, the for future, the P0815 and the A42. However, with graph, you're breaking down kind of that categorization structure of the tables, and you're pulling individual pieces out separately and then directly creating those relationships in physical storage, so that Alice, an individual node here, is going to be tied directly to the departments that she belongs to. Same thing if you're dealing if you're more familiar with key value stores or document stores, converting to graph, we have our key value store in the upper left. We have a key tied to a value, which could also have other keys attached to it. And in graph, you're breaking that structure into individual pieces and then directly relating those pieces together. Same thing with document. We've got kind of this nested sub-document structure where it's kind of a hierarchy almost. You're pulling those pieces out of the hierarchy and directly connecting them with relationships in the graph there on the right-hand side. So again, usually when you're looking at other types of data stores or data formats, graph is going to pull the individual pieces out separately and then directly connect those pieces. This means, again, that you're not pulling unnecessary data that you don't care about because it's not grouped together. It's all individual pieces directly linked. So graphs then add context and meaning to our data. We have kind of a person down there in the lower center. It actually is based on me, but could be anyone there. And then we have an is friends with relationship to the person there in the upper center. So with that relationship there, we're saying, okay, this person could share an Uber ride, or this person could go to the same conference, or this person could happen to visit the same coffee shop or with this other person. But no, we've actually given context to this relationship and say, no, this person is actually friends with this other person. And we have a specific date on that friends with relationship. So then we can kind of quantify how valuable is this friendship? How close are these two people? What does that mean? Should I be able to go to this person for references and all sorts of things? But again, you're kind of adding context and value to the relationship that exists between, in this case, people, but all sorts of other things. Same thing with Jennifer there. It's going to the graphs technology there on the left. Could be any sort of relationship. I could work with this technology. I could have just heard about it in passing. No, I actually like this technology. Works for company. I could be a liaison or a contractor or permanent employee or retired or et cetera. But no, I've got a works for relationship. This is active, live, happening now. So let's look at just a few use cases to kind of get a better idea of the variety of things that graph can do. The first one that usually people think of is the social network there in the upper left. So this is usually social media cases, although not always. You could do organizational hierarchies and kind of just people connecting to other people. You could look at a train station hub and see how people kind of move about. Things like COVID graph and stuff like that is another good example of how transmission works with diseases. But basically just looking at how people interact with other people, and how you have groups that kind of form, communities that form, or how they might break apart, because of some disaster or bad relationship, et cetera. So that's kind of a common one that a lot of people think of, but of course it could be broader than social media on its own. Fraud detection there in the center is another good one. This is not just now incorporating people, but it's pulling in other sorts of data. So you have now bank accounts and credit cards and personal identifying information and possibly loans and other sorts of financial data that all kind of come together to form this picture and patterns of behavior for a user. So then it's really the case of, I want to find what's kind of abnormal or unusual behavior in kind of a bank case. So for this instance, you can kind of see you have a couple of account holders there sharing a social security number there in orange, which isn't good, right? that should never be the case where you have two people sharing a social security number. There could be other things too, where maybe they share a phone number and maybe they also share a bank account and they share credit cards and all sorts of things. All in those individual pieces might not look suspicious, but coupled with some other things, maybe passing a lot of money back and forth between the two people, et cetera, it kind of looks suspicious and abnormal behavior. And so then you can bring up these red flags that say, hey, this is unusual behavior for any type of user that we have. Therefore, I'm going to flag this as fraudulent, and we can look more into this, or we can shut their account off, or however you want to deal with that. So another really interesting use case, then kind of creating this picture of a person's financial information in order to better detect when something might be abnormal or unusual to catch fraud. Network and IT operations there on the right. This I really like because it's actually a physical representation of a graph, as well as storing it in the database. So this is tying together your routers, your network, your switches, your cables, your printers, your desktops, etc., and physically showing how they're connected in a room or building or campus, potentially. But then also storing that data in Neo4j, so you can understand kind of how long the cables have been there, whether, okay, if this cable needs upgrading, what devices is that going to impact? If I have a slow connection going on, well, what might be the reasons that this is slow? Can I go in and physically replace this cable? And things like that. So again, a physical representation of a graph in the real world, as well as then modeling that same thing in Neo4j or in a graph database in a virtual space. So it kind of really demonstrates that very visible kind of physical representation, which we'll actually talk a little bit more about here in a minute. So the next use case there on the bottom, identity and access management. This one I find really interesting because I've always found identity and access management to be super complicated to figure out who has access and why they have that access. And well, wait, they have access to this or this resource. How did they get that? Oh, it's because of this role. And okay, this role gave them read access to this, but oh, it gave them this other role gave them write access to that. And I find it super complicated. So being able to trace through the graph and understand, okay, this role has given them access to this resource and this person gave them the access. You can literally trace back almost like a map to find the route that these accesses have taken. And then finally, graph-based search, which is where a lot of graph technologies kind of got their start with this use case, basically trying to find better results for people's searches, or trying to give better recommendations and that sort of thing by looking at the area of the graph that's related to what you're searching. Okay, so here's a couple actual live use cases. Neo4j likes to use the slogan, graphs are everywhere. And so this is kind of showing that just a little bit. So on the left-hand side there, we have the internet. These are pages linking to other pages. You can see kind of that cluster in the middle there. These are kind of highly influential pages. They have a lot of links to them. They might kind of link outward quite a bit and kind of share other pages. It could also be something like a search engine, so something like Google, etc. And so this just kind of helps you understand which pages are more influential in the internet, and might cause a problem if one of them goes down. Maybe something like Amazon or Google. If we lost one of those pages, we might be in real trouble. So then on the right hand side, we talked a little bit about bank fraud already, but again, just looking at behavior and how kind of different types of information connect together, and what's kind of typical patterns or behavior in a financial network. And then there's a couple kind of less well-known or kind of more unusual use cases. The first one there on the lower left is the NASA space satellites. So super expensive equipment, kind of delicate, probably a bad thing if you lose stuff like this, but being able to know what's in orbit, where it's sitting, what other devices might be able to communicate with it, or maybe who could possibly get to it to work on the equipment, etc., where it might land if it comes down, all those sorts of things. You can store all of this information in the graph and physically see what we can't see from the ground, right? So this is, I think, super interesting and helpful, and kind of one that you don't think about using a graph database for. And then finally, on the right-hand side, the Game of Thrones, or Graph of Thrones, as we like to tease, family tree. So even though this is kind of a silly, lighthearted, fun use case, this can be used for things like organizational hierarchies, or even genealogy, personal genealogy trees, and things like that. when the Game of Thrones series came out, on the TV series started coming out, people were going back through the book series and then also pulling what data they had about the TV series and dumping that into a graph database and trying to see if they could predict who would kind of get together or who would have a battle or who would become enemies or who would end up on the Iron Throne or who would end up dead at the end of the series and those sorts of things. So really interesting, again, to kind of just understand relationships and kind of patterns and behavior of people and how relationships form or pull apart, and what that's going to leave you at a certain point in time. So again, even though this one is specifically is kind of not business applicable, it still can be in other respects. So let's look quickly at the data model for a graph database. And I did mention physically representing data in the real world as a graph. And this is what the Neo4j data model, as well as several other graph vendors too, offer, is whiteboard friendliness. So basically, that's a term that just means it's easy to represent the data as it actually is in the real world, and basically convert that over to graph and show that in a graph database. So let's look at kind of the graph components and build up our graph here. So we have nodes that represent the objects in the graph. You can categorize those nodes using labels. Labels are optional. You don't have to categorize, but it does help with performance of your queries. And also if you do any sort of visualization and things like that, it can kind of visually help you categorize and group entities together. But by no means are you required to put labels on anything. And then relationships, you can connect nodes by type as well as direction. So here we have our nodes, we've got our relationships that we've added. You add a relationship type, which is that is friends with or works for or likes relationship there. And this basically quantifies and helps you understand the relationship between two nodes. And then you also have a direction as well. You store that direction, but then you can query in either direction, actually. So we call them bidirectional relationships. On write, it's going to be a specific direction, but when you read it back, you don't have to specify a direction. It'll pull it anyway. And then last but not least, we have properties, which are basically name value pairs. You can apply these to nodes or relationships. And again, just kind of hydrating this model, adding more metadata and more meaning and value to the data that you're storing in there. So things like name, properties there on the person nodes. We have a name for a company as well. We have a type for technologies. And this helps us understand, again, how these nodes are related and then form a better picture of, in this case, somebody's network, to help understand that. So there's some tools out there for data modeling. I wanted to throw kind of just a few links out there for this. The arrows tool, which you'll actually see an image of here coming up. This is a good one for basically just whiteboarding, drawing pictures of graphs, developing kind of a data model, a base level data model, really good for that, super helpful. We do have several developer guides out there. The second bullet that talk about data modeling, kind of the choices that you might make based on the business decisions you have to make. We do have a Graph Academy course that's all about graph data modeling. It's self-paced, free, online, all that sort of good stuff. So you can check those out. We've got a bunch of other courses as well, but I specifically wanted to mention the data modeling. And then of course, if you have questions about data modeling, we have a community forum that you can go out there and create an account and ask all the data modeling questions you want to. And whether it's Neo4j experts or kind of some experts in the community, will be able to help you and hopefully improve things. So let's apply all the tools that we've covered so far, which is quite a bit, to the scenario that we were talking about. Remember, we were asking questions about JDK and how upgrades might work, or what would be the changes all involved in an upgrade. And so talking about this whiteboard friendliness, this is the initial thing that I might go to the whiteboard and kind of draw up for our data. So we have these Java versions. We're going to have diffs between the Java versions. And then within that diff, we're going to have a bunch of changes that are going to occur. So within Java, you have modules and packages, depending on which version you're dealing with. The later versions have modules first and then drop into packages, where the earlier versions of Java drop straight into packages. Then within packages, you're going to have interfaces, class, and enums, or interface, class, enum, and annotations, excuse me. And then within those for, you're going to have fields and methods that fall into those. So you kind of have this, what looks very complicated. But if you think about the Java JDK, if you're familiar with kind of its setup, it's honestly not as overly complicated as it looks on a whiteboard. So I would kind of go to the whiteboard and I would draw this up. This is kind of the dependencies and the tree and hierarchy that we'd be dealing with. And then I might go to something like arrows and kind of model this a little bit nicer, format it. Maybe I could show this to my colleagues, my boss, my teammates, maybe business users, and kind of get their sign off, or, hey, how does this look? Or this is kind of the domain we're dealing with. This is how I understand it, etc. And then when I actually go to store it in the database, this is going to be the model that I'm going to get. So this is how my data is going to be stored in the database itself. And so you can see that the data that I'm actually storing in the database is really, really similar to how I drew it on the whiteboard in the first place. So this is when we talk about the term whiteboard friendliness, or other graph vendors, I think, do this too, or we talk about whiteboard friendliness, they're really saying that how you would go to the whiteboard and draw your model for the data domain that you're dealing with is as close as we can possibly get to how we actually store it in the database. And that was kind of the whole point of the graph database, was to try to make it easy for people to take their data domain. This is how it's physically represented in the real world. Okay, how can we store that and make it performant in a virtual setting, in a graph database in this case? So that's super nice, really helpful. Let's talk a little bit about Cypher. So, okay, now we understand how to put together a graph. Now we know how to take our data domain and kind of put it into the model that we want. But now how do we query it? How do we access it? How do we maybe dump the rest of the data into the database, et cetera? And we can do this in several ways, but one of those is the Cypher query language. So we're going to do just a really quick overview of Cypher, which is basically SQL for graphs. It was designed to be the version for graphs that the SQL is to relational databases. So Cypher is based on ASCII art, which means it looks really pretty, but don't be fooled. It actually is really functional as well. It also just means that it's super easy to maintain and easy to hand off to other developers, et cetera, because it is so visual. It's a declarative query language, so it focuses on what to retrieve, but not how. So you're not going to go in and specify, hey, I want you to do it this way. I want you to go about running the query this way. You say, this is the data that I'm looking for. And then it will say, this is the best way to go about retrieving it, and gives that data back to you. So let's take a look at how we would write this. We have a person here, works for a company, and we want to put that into our database. So the Cypher statement there right below it is what we're going to use to do that. So we use the create keyword, just basically like a SQL insert, if you're familiar with that. And then we need to create two nodes in a relationship, right? So we have our two nodes, those are inside parentheses. And if you bring the parentheses together, you're actually going to get a circle, which is exactly how the visualization right above it is showing the node. So again, very visual, yet very functional. So everything within the parentheses then is going to be all about your nodes. And then you can see that relationship in the middle is kind of an arrow with brackets and the relationship type in the center, which looks very similar to actually how it's visualized up above it there. Then within our parentheses, within our nodes, we're going to specify a couple of different things. We're going to have labels that kind of categorize nodes. We have one person node, we have one company node. And then we'll have our properties there in curly braces. So we have, again, key value pairs is how these are structured. So we have our name, Jennifer, or our company name of Neo4j in this case. So that's how we would create that data in the database. Now, how would we retrieve that back out of the database? Basically to query it. So we would use the match keyword, which is basically like a SQL select, if you're familiar with that. We know we have a person with a name of Jennifer. That's our first node. We know there's a works for relationship there, but maybe we don't know what other node exists on the other side. So we can say, okay, we have this node, and we're going to call this whom, because we don't know who Jennifer works for. And then we could return anything the database has about that variable whom, which in this case is going to return Neo4j, because we just stored it that way. We see the image right there above it. We know that's the details it's going to return, but we could write the query this way and it'll return all that information for us. So an overview of Cypher in about 20 seconds here. Nodes are inside parentheses. You can have variables and labels to help categorize. And then you also have your property keys and property values that you can specify within curly braces there. So variables just allow you to be able to use that same entity, that same node later in your query. So you can kind of chain queries together and that sort of thing. Relationships are going to be very similar. So you have kind of that variable and then your relationship type, or you can think of it as kind of a relationship label, if you will. And then you have that arrow and bracket structure that looks very similar to the, again, how the data model is in the database. And then you can also have property keys and property values within relationships as well, that you can see there on the right-hand side in the curly braces there. So at its core, Cypher is just looking for patterns of those nodes and relationships. So it's going to be looking for node, relationship, node, relationship, node, relationship, as many as you specify, and just basically traverse the database like that. So that's at its core what Cypher is. I'm still learning quite a bit about Cypher. I know this is a way oversimplification of it. There's a whole lot more power and things that it can do. But this is really what Cypher is all about, is it's pattern matching. It's looking for patterns. So there are some tools for Cypher if you want to learn more about it. There is a ref card. So if you like printing out your ref cards and tacking them to your wall or your office, however you might be stationed right now. We also have some developer guides to talk a lot about Cypher and dive into kind of more of your kind of base level functionalities and things there. We have a Graph Academy course as well, all about Cypher. Focusing on that. And then the Cypher manual, if you want to dig into the reference documentation and things, those are always available. And then of course, if you have questions, feel free to come to the community forum and ask those. Us or others in the community who have knowledge as well are happy to answer those and help you along. So let's talk very briefly about data import. So there's a variety of different ways you can import data, as with most data stores, right? You can write Cypher statements or a script, just like you can SQL scripts or anything else. We also have a tool in in Cypher called Load CSV that helps you load kind of small to medium data sets with CSV files, or it also accepts PSVs and that sort of thing. So any delimited file like that, flat file you can do. ETL tool is a good one for coming from relational database and basically just doing an initial dump. So it translates that data and does an initial dump over into your Neo4j instance. So this is really good for kind of an initial look at your data in a graph, or just kind of taking what you already have in a relational database somewhere and dumping it over to Neo4j. Kettle, if you're already familiar with Kettle, this might be a good thing. We've got some plugins and things that you can take flat files, or you can go straight from a Neo4j database or any other database and dump into Neo4j. So Kettle, I think personally has a little bit of a steep learning curve, but if you're already familiar with Kettle, this may be a great option for you. APOC, which we'll talk a little bit more about in a second, is a utility library that has a ton of procedures and functions for a variety of different things. This one is super flexible and capable of doing a lot of different sort of things for import. So this is one I kind of gravitate to for most of my use cases. Neo4j admin import tool, good for bulk dump data sets, usually flat files there as well. And then you can also do it import programmatically from your drivers. So if you're dealing with Java or PHP or Go or Python languages, there's a variety, a whole lot longer list than that. But you can move data programmatically using those languages to dump into Neo4j as well. So let's talk quickly about APOC. There's tons of utility procedures there. We kind of like to refer to it as the Swiss Army knife for utility library for Neo4j. It does a lot of different things and it's very capable of doing them very well. So it handles a lot of different data formats as well as coming from different types of data stores. It's really good for flexibility for your manipulation and your data cleaning. So if you need to massage data or manipulate it or tweak it or clean it up, APOC usually has several different procedures and functions that you can use to get the data into a nice, neat format for your graph. So super helpful. Definitely a tool that I recommend checking out first. And then if this doesn't kind of suit your needs, there are plenty of other methods to choose from. So some tools for APOC. We have a labs page out there that links to a ton of other resources. So I've put that first. But within that, you also have documentation. There's a YouTube video series that walks you through actually using these in the real world and applying a use case to them. And then, of course, there's a whole separate section in the community forum just about APOC. We get a ton of questions through there on APOC, so feel free to reach out there as well. Okay, how do I get an instance of Neo4j? Because so far this is looking good, maybe for our use case, but is it really complicated to spin up an instance of Neo4j? Because otherwise, why would I mess with it, right? So here we'll talk, there are some free tools and there are some, of course, costly tools. We'll talk first about the free tools and then I'll kind of mention the others as well if that's what you're looking for. But Sandbox is a good go-to. This is a trial instance, usually for about 3 to 10 days. And it usually comes pre-populated with some data sets. There is one blank sandbox that you can dump your own data into, but most of them come pre-populated. And there's usually a guide with it as well to walk you through and help you explore the data and understand what the graph is doing. So really good for kind of introductory, how do I use this? What do I use it for type of thing. Or a free tier is there on the next line. This is recently released and you basically get your own Neo4j Aura instance, which is a Neo4j managed cloud instance, basically. And this is a free tier, so no cost to you, and you can pull in your data there. It's a little bit more kind of hands-on. There aren't really a lot of tutorials or step-by-step guidance through the Aura free, but if you're kind of already past that point or you want to get started with your own data, I would highly recommend going straight to free tier on Neo4j Aura. Neo4j Desktop is a downloadable kind of program that allows you to create and spin up multiple local instances or connect to remote instances. So it's kind of a hub, a developer hub for a lot of different Neo4j instances. But does require a download if that's something you can or can't do. There is a server installation that's also free. It's called Community Edition, and that is available for download out on our website too. Some of the features are a little bit restricted, so you're not going to get kind of the full Enterprise Edition feature set. However, this is a good place to start, and if you're looking at kind of a server installation with just basic functionality and kind of get started and understand a little bit more about the database itself, this is also a really great option. And then, of course, there's always Docker. So we have a couple of different containers out there right now. We've got just the basic Linux or x86 version container. And then there is also an ARM64. I'm currently running on Apple Silicon, which is that second one. So I have to use the experimental Docker image. However, the experimental, I haven't had any issues with it. And hopefully it will actually go to an official image here coming up in the next rendition of Neo4j here soon. But that is what's available for that right now. So do be aware if you're running kind of different architectures, you might need to pull a different container for that. So that's everything that's free. There are several other ways to deploy. So you can run in any of the clouds, more of your public clouds, as well as a bunch of others, but GCP, AWS, Azure, all of your big players, as well as some others too. Most of those, I believe, are bring your own license. I think there might be one or two that now support Neo4j Aura instances, but most of them are kind of going to be a bring your own license and bring your own instance kind of thing. You can just connect via those clouds. And then you can also run physical instances of Neo4j if you want to host all that and do all the infrastructure yourself. So things like Docker, Neo4j Desktop, again, you can connect to remote instances, and then Neo4j Enterprise Edition server, that's available there as well. So lots of options if you're interested in kind of the more business use case commercial licenses, but I kind of focus more on the developer friendly entry stuff, and that's going to be more of your free tools. So I'll talk very quickly about Neo4j Cloud. It's our database as a service. Neo4j Aura is what we've called it. It is entirely Neo4j managed. So if you're a business, this reduces maintenance and provisioning. It avoids staffing and skill training. It avoids downtime and improves reliability of the instance. And the way that we charge for our Neo4j Cloud, so if you go on up to different tiers of Neo4j Aura, the way we charge for Aura is based on resource usage. So this is basically like every other cloud provider out there. Your big players, AWS, Azure, and GCP, all charge based on resource usage as well. So this is no different than if you go to any other cloud provider. This is just a Neo4j hosted version of that, basically. So here are the different Aura tiers. Again, I focus in on that Aura free tier. They're all the way on the left. You get a single database. There is a limit on graph size. However, I have yet to hit that. So it's been pretty robust and pretty good for everything that I've needed to do on it. You do get multi-tenant infrastructure, and you get the APOC library automatically built into that, at least most of it. And then, of course, if you're concerned or want to know more about the business use cases for your business or your enterprise, we do have 2 other tiers that provide more customer support and, SLAs and things like that. So those will kind of be kind of a sliding scale if you go on up, but those are there just to let you know. So I mentioned both Aura free tier as well as Sandbox. What's the difference? Why would I pick one over the other? Aura free, you're going to get that instance forever. Whereas Neo4j Sandbox, it is a temporary instance. You only get 3 to 10 days max, and then it just shuts down after 10 days. Aura free, you always get the latest features and versions, because a lot of times we roll out the features and versions to Neo4j Aura before we roll them out to anything else. It's almost like a test case. Aura is very secure and safe and robust. And so we roll a lot of our features out there first before you have official release cycles for your other products. Where Neo4j Sandbox is actually maintained by my team. And so basically it's just, as much as we can get a resource to do it, when the next new version of Neo4j comes out, that's when it actually gets upgraded. So you may not always get the latest features, the latest functionality, because we may not have gotten to that just yet. So there's some downsides with Aura as well. There's some great things that Neo4j Sandbox handles super well as well, but kind of just give you some pros and cons to weigh the value there. Let's talk a little bit about building applications, and then we will dive into a little bit of a demo. So being a Java audience, I wanted to focus a little bit on that as well. We have lots of language drivers. So I mentioned you could import data programmatically using a lot of different kinds of languages. So, Python, Java, JavaScript, .NET, Go, Ruby, PHP, etc. There's a bunch of drivers, and we have several that are officially supported, so come straight out of Neo4j engineering. And then we have several that are built by partner companies or really phenomenal community members. And so we have some really great community drivers out there as well. And sometimes people prefer the community driver over the official driver. It just kind of depends on your use case, but don't discard those. There are some really great options out there as well for pretty much any programming language you could possibly think of. There are a lot of plugins and extensions and libraries with Neo4j. We already talked about APOC. If you're interested more in the data science capabilities, we do have a graph data science library that's available commercially. And then we have an integration with GraphQL. That's a GraphQL library that is supported by Neo4j. And there's lots of others as well. So tons of integration projects, extra libraries out there for anything under the sun, like visualization or data import to different types of data stores or analysis and that sort of thing. Integrations are with different types of frameworks. So we support Spring with Spring Data Neo4j. I've got quite a bit of material out there on Spring Data Neo4j. And if I'd had time today, I would have loved to show some of that to you guys, but feel free to check out a lot of our information on Neo4j, as well as kind of my content hubs as well. We also have a couple of developer guides out there. I mentioned those earlier that talk about Micronaut and Quarkus as well. I haven't personally had a chance to look at those 2 frameworks with Neo, but others in my company have and have written some stuff about that. And then we also have integrations with Kettle and Spark, Power BI, JDBC connections, and tons more there. So there's lots of capabilities for plugging into different kinds of frameworks and architectures and systems and databases and all sorts of wonderful things. So you can write all sorts of applications with that. So closing then, let's kind of pull up our demo and we'll walk through our use case a little bit. I'll talk more about queries and maybe kind of show off a little bit of Spring Data if I get a second, and then we'll wrap up with some resources. So I'll switch over here and I'm going to expand my window here. So this is the console for Neo4j Aura. So I've got a link to it on the last slide, but it's just console.neo4j.io. And I can spin up, if I go back to my main databases page here, I can click create database. I only get one Aura free instance, as does everybody else in the globe. So Neo4j employees don't get any special treatment. But I've already got my free instance running, but you can create other instances and then you can scale up or scale down your instance, and it's going to tell you exactly how much that's going to cost you and all sorts of wonderful things there. But I'm just going to stick with my free instance for today. Much safer. Not gonna charge my department some money. And then let's go ahead and open Neo4j browser. So I mentioned our JDK data kind of seems forever ago, right? We've covered a lot of ground since then. Let's walk through and look at kind of how the data is actually in the database, and then we'll run some queries on it. So I'm going to do I'm going to call it an APOC procedure, actually. We do have one that's built into the database to show the data model, but it's got a bug right now, and so that's being worked on. So I'm using the APOC version of this. The APOC one's a little bit more customizable. You can actually have it, remove or show certain things or hide certain other things. And so I didn't do that, and I'm actually going to focus in on I'm going to remove some of this because this is extra stuff that I had for my Spring Data app, and I don't need that today. This is the other one I need to clear out. So comes back, and I don't know why it doesn't remember that. Okay, so we have our Java version here in blue. Let me see if I can bring this up just a little bit more. That's better. Have our Java version here in blue. We have a couple of relationships because remember we have a version going to a diff, and that diff is going to connect to another Java version. So you're going to have a diff between two different Java versions. So you're going to have two different types of relationships. You have a newer Java version going to a diff, and you have an older Java version going to the diff. And then depending on the Java version you're dealing with, so your later ones are going to start with modules as the kind of base level kind of grouping or categorization of the JDK, but your earlier versions go straight to packages. And then you have interface, class, enum, and annotations. And within that, you have methods and fields that connect to all those. So with that, this is kind of the data model that we're dealing with. This is what we showed on the whiteboard, and I showed actually looks like in the database. You can see that physically represented here. So this is just basically looking over all of my database and saying, this is how the data in here is organized into these kind of categories with these relationships, et cetera. So it kind of does all of that for me. So, okay, we've looked at our data model. Now, maybe we want to explore this data just a little bit. Let's see if we can find all the active versions of Java. So we're going to look for a Java version. And when I looked at this, let's just actually return all the Java versions. There are only like 18 of them total, right? So we've got a few nodes here. We can drop in on one of them, click on one, and we're going to get some details. These are all the properties that I have stored about this entity. So I have an API spec doc that I can click and open up. There's a bytecode number there. There's a code name if the version happens to have one. There's an end of life date, so basically when it's no longer supported, or a GA general availability date when it gets released. There's a language spec doc link here. I have the name of the version. I have a status, so whether it's end of life or still being maintained or still available, et cetera, the version it is, and then a VM spec link as well. So with that, I probably can just look for anything that's not end of life yet, right? So let's add that in. So match Java version where j.status is not EOL. So end of life. Let's see what we get. We get 5 entities back. But if we click on this, we can see, okay, Java 17, the status is dev, so it's not end of life. However, the GA date is actually next week. So it'll be released next week, but it's not available yet. So, okay, I can't use this version because it's not out there yet. So let's tweak this a little bit and let's make this a little bit better. So I'm going to say j.ga date is greater than today's date. So I'm just going to use a date instant in Cypher. And today's date is less than the j.eol date. So this should tell me, oh, wait, I didn't do that right. Greater than, it should be less than. And then the EOL date, yeah, less than, yeah, today's date less than the EOL date. Okay. let's try this again. Okay, that's better. So we get Java 8, Java 11, and Java 16. And we can return some more details about this. We could get back kind of our j.version, and then we can return the j. Let's say status, j.ga date, EOL date, and kind of return a table format, if you will. So we have our Java 8, which is an LTS version, long-term support version. The EOL date, it won't go out until 2026. So it's got several more years actually that Java 8 will still be supported. Whereas if you look at Java 16, it's actually going to go out next week. So it'll no longer be supported, looks like when Java 17 comes out, which is kind of interesting there. So we can return data in a variety of different formats. You can also kind of play with the tabs along here on the left-hand side. You can return kind of a formatted table version, if you will, or there's a kind of JSON request and response format here as well. But I like this format. Okay, so now let's say we have a particular project that was created at a certain date, and we want to see what the current Java version was for that date. So I'm just going to create a sample date here. So I started my first job in 2013, started November 13. So this is the date that I started my first official Java programming job. And so I'm going to match the Java versions where the GA date is less than my date, which is less than the EOL date. So basically what was current for that particular date. And then let's go ahead and just return everything. There shouldn't be much. So Java 7 is what was in and what was being used at the time that I started my first Java programming job, which is pretty cool. Okay, so let's say we're dealing with Java 8, because that's an LTS supported version. And we want to find out how many upgrades we need to do in order to get to the current version. So we're going to have Java version, and we know we're starting from a version number 8. Right? So that's what our project maybe happens to be. And then we know this is coming from this is going to be our older version. We want to find the newer versions. So we're going to need to look for diffs that go to a newer version. So this is our older one. So from older to a version diff. And then we're going to basically have the opposite end here. So we're going to be coming from a newer version on the other side. And then we're going to have another Java version, and I need to name it something different so that the variables don't get confused. And then I do want to find out, what's not end of life, what's current, right? So where our Java version, okay, yeah, where our second Java version, the newer Java version, where the GA date is less than today's date, and our other Java version, the status is not end of life. So basically we want to make sure it's a current version, all that good stuff. And then we can return our Java, or let's just do our j2.version, and we're going to order by, I'm going to convert this to a float because we have some Java versions that have a .0 or .0 on the end, and some of them that are just a plain number. So I convert everything to a float, and then I can sort correctly. So I have Java 11 and Java 16. So I would need to go to either Java 11 or Java 16. And this would be kind of my upgrade path, because now there's a lot of versions in between there, right? But the key is that they're EOL. So unless I have to stop at an EOL version in order to get to the next version, why would I upgrade to something that's already end of life? So I would need to either go from Java 8 to Java 11 and then to 16, or I might need to go either to, Java 8 to 16, or maybe it requires me to go to Java 10 or something in the middle, but Java 10 is already end of life according to this. So I would want to probably just hop to 11 if that's going to be feasible. The other way I could write this, because I can use this where I look for anything that's already GA and the status is EOL. The other way I could write this is actually using the dates. So where let's convert this to an, oh, you know what, that's, oh, it already converted it for me. That's interesting. Okay. So yeah, I thought I needed to use this. I thought it was storing the date as a, when I imported it, I thought it imported it as a string. And so I would need to do this date conversion basically to get it to a ciphered date, but it appears it was actually going ahead and either it already was a date format when I imported it, or it was already doing the conversion for me. So I didn't need to do that. So basically where our GA date is less than today's date, which is also then less than the date of the EOL date. So I could either look for a status of EOL, or I could actually just compare the date and say, I want to make sure it's not EOL yet. So 11 and 16. But if we return, let's return the j2.ga date and j2.EOL date. Again, we notice that Java 16 is about ready to go end of life. So if we wait until next week, we could actually go from 11 to 17, right? Hopefully. So one interesting thing there. So with that, let's just kind of take a quick look at some Java versions and then their diffs. So we have Java version, and we're going to just pull any relationship for right now. And we're going to pull a version diff, and we're going to return. Let's just pull everything. There shouldn't be too much. Oh, and I'm going to go ahead and grab the other relationship on the other side here for the second Java version. So we want to pull different Java versions that have diffs between them. This might take a couple minutes to run because there's a lot, which I didn't actually, it was really fast. So we have our version diffs, and we have all the Java versions between them. And we, of course, could kind of sync this up and organize them a little prettier where we can see these a little better. So I like to kind of line my Java versions up, and that way I can kind of see in order some stuff. But again, you could do some better analysis on this, write some queries, but you see we have quite a few version diffs that are going back and forth between our Java versions. And again, some are being compared as older versions to other newer versions, or older versions to other older versions, or you're dealing with newer versions that are all going to old versions. So that's kind of an interesting data set. You can click around, you can explore. There's also visualization tools like Neo4j Bloom that allow you to just kind of peek through and walk through and pull in different nodes, different places, all visually, and query using kind of a natural language type of process there, which is kind of fun. All right, so maybe now I'd want to find out which packages or modules had the most changes in the Java versions. So which ones over the course of Java's lifetime have changed the most or the least, maybe. So we'll start first with, we're going to look at version diffs. We know we're going to have relationships of has delta, because this is how our data model, we go from Java version to from newer, from older to a version diff. And then we're going to have all of the deltas, all the changes, multiple levels underneath that. So we're going to just look for any delta, oops, mistype, here on the other side. And then we want to find out where that delta is either a module or delta is a package. And then let's go ahead and return the name of the delta and maybe the count. So again, what has changed the most as count, order by name, and descending order. Let's run that. Okay, so the packager module that has changed the most, and I could actually return the label and stuff with this, I just didn't this round. So is the javax.xml.xpath. So that has 101 changes between the different versions. So that package had a lot of stuff going on over the course of what 18 Java versions looks like. So a lot of changes going on there. We could also remove this descending and only it defaults to ascending order. So we can find out which packages or modules change the least. So the java.activation package or module only had 16 changes throughout the entire course of the Java lifetime, which is relatively few, I think. And so that's really interesting to find out, okay, maybe I have one particular package. Order, yeah, oh, actually I could order by count. That would have been the better thing to do. That's what I should have done. There we go. Okay, so it's this java.rmi. Sorry about that typo. That actually had 133 changes to it. And then going the opposite way is the java.activation, which only had 16 changes to it. So I ordered by the wrong thing. Oops. So really interesting to know, maybe I'm using a package or two and I want to find out, okay, which packages have changed the most, because maybe I'm looking at maybe 5 or 6 upgrades. And so if that's the case, what packages are going to probably be most impacted by upgrading Java? And you could find this out with that. Now, I mentioned like the second slide that I did, I wanted to know which changes had affected java.time package. So let's actually look for a particular package here. And we know we have a package name of java.time. And then we're going to go straight over to a delta. So a package, remember, has version diffs that are connected to it. At a higher level. So I'm going to do delta and it's going to a version diff like that. But remember though, that the package could either be the first hop from version diff or it could be 2 hops from version diff, because you could actually go through modules first if you're dealing with later versions of Java. So in order to accommodate this, I can actually do what's called a variable length path and say, I'm going to traverse the has delta relationship from version diff to a package that's at least 1 hop with a maximum of 2 hops away. So I can do kind of a variable length path search here. Imagine trying to do that in another type of data store. Super complicated. And then I want to pull the newer Java versions from that. So I just want to find out the from newer relationship. I don't care if you're coming from an older relationship or from an older Java version to something newer. I just want to pull anything that's going to be newer. Java version here. And then turn. So individual versions, there could be multiple changes to that package, so possibly multiple patterns. And so I'm going to say I want to pull a single version, single instance of a version, and then I'm going to do some fancy stuff here. So bear with me for a second. Oops, actually this. I should have had a path here. Yeah. That's right, isn't it? Nope, I don't need to do this stuff. This is wrong query. Silly me. Okay, I'm just looking for a package. Sorry about that. Java time has delta, version diff to another Java version. And then I just want to return the distinct version. And then order by. And again, I'm going to just wrap it in a 2 floats so that I can order it correctly. Yeah, that should do it. Okay, so of the changes to the java.time package, I only have 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So there were a lot of changes, basically every version starting from Java 8 on up, a lot of changes to the java.time package. And actually, when I looked back through this, I realized and remembered that java.time, the date and time API, was released in Java 8. So this is the reason why we don't see anything smaller than version 8 here, because java.time did not exist before then. So now I could actually do something really interesting. So now I know that what was used before was the date class. So now I could find which versions had changes to the date class. And so to do that, I'm actually going to create a path, which means that I can reference kind of the whole grouping of the path together. And it's still not something I'm super familiar with, but I've done it some, and it works well. And it actually has a lot of powerful capabilities for like inspecting a whole path and things like that. But we're gonna again look for that has delta relationship. And now, since we're looking at a class name, remember class is one level down from your package, which means it's also potentially one more level down from your module. So we're dealing with at least 2 hops, possibly 3 hops back to our version diff here. Version diff like that. And then I want to look for, again, our newer Java versions. So from newer Java version. And now I'm going to do some fancy stuff here. got my memory all discombobulated there. So I'm going to pull again distinct Java versions because there could be kind of multiple paths and patterns. And now I want to pull distinct, and I'm going to be basically doing an introspection on the path that I specified up there. So it's on my path where the node has a package label. So I want to pull the packages that are involved that are involved with a date class change. So if I changed, if the JDK changed the date class, I want to find out what packages those exist in so that maybe I can search for any import statements that import those packages, right? And I'm going to just pull the name back from that. Okay, I've got all my parentheses and everything good there. And again, I'm going to order by the Java version just to keep it kind of consistent and looking nice. Okay, so starting in version 1.2, you can see these are mostly smaller versions. However, it does look like the later versions still have this date class involved, but the packages that are involved are the java.sql and java.util. So anytime I'm importing those packages, I'm going to know that, hey, this project or these classes are going to need to change because the import statements might need to change, dealing with those. Okay. The last question that I had on my slide was, okay, if I'm going from one particular version to another particular version, what are all the diffs and potential things that are going to change with an upgrade from one version to another? So I'm going to match a particular Java version. And in this case, we're going to go straight from version 16 to version 17. So this is my older version. So therefore I'm going to have oops, if I could type, that would be great. From older. And we know we're going to go to a version diff. That. And then we know that this is going to be a newer Java version. So here from newer, and we want to go to the next Java version up, which is going to be 17 version. And then 17. So now I want to take the diff that I just pulled from that pattern, and now I want to pull all the deltas that are associated with that diff. So match diff has, I'm going to use a different variable there, has delta to, let's just say any delta, because we don't know if it's a package or a class or a field or an enum, etc. Now, remember, we have multiple levels here. So our has delta relationship, we could go to module and then to package and then to kind of our class level and then our field and method level. So that's potentially 4 hops. But of course, if we're not dealing with our module, it could be a little bit shorter. So at least 1 hop up to 4 hops away. And then we can return our delta. our relationship for our has delta, and then the actual delta itself. And let's return our graph. And this might take a couple minutes to run because it's basically got to do two match queries together in order to pull this data back. But what we should get back is our graph of all of the changes that have occurred between 16 and 17, and therefore anything that might potentially impact us. We could also see how large the change set is and kind of get a better idea. And I'm kind of surprised it's running this long already, because I think it was faster than this when I ran this before. But it might take another minute. So with that, we will, when we get through here, I don't have time. In fact, I'm already running over. I don't have time to go back and do any specifically Spring Data Neo4j stuff, but I'm happy to do that at another time or answer questions if that comes up. And then we'll kind of wrap up with a couple of resources and call it good and switch over to questions. But this is taking forever to load. Oh my goodness. Well, I'll go ahead and switch over. It did not take that long yesterday. I don't know why it did that. It's 16 and 17. I should all be right. Okay. Well, I'll keep an eye on it and I'll hopefully show the results here in just a second. Okay, so resources, if you're interested, I mentioned Neo4j Aura. That's what I did the demo on today. The JDK data repository, if you're interested in copying the data that I have in my database, I have all of that information as well as the sample queries that I ran today out in that repository. If you want to look at a Spring app using this data, I also have that on my GitHub. I mentioned the developer guides. They talk about a lot of different things, kind of walkthroughs and tutorials on data import or cloud frameworks, language drivers for different types of programming languages and visualization. We do have an online meetup that posts to YouTube, Twitch, and Meetup, all three. So if you're interested in keeping an eye up, keeping up with us there are, I think, 3 certifications now, but there's a general certification for Neo4j if you want to check that out. There's lots of information around that, how to study and all those sorts of things. And then, of course, I mentioned the community forum where you can ask questions and get help from experts, Neo4j people, as well as fabulous community people there. And then my information is there in the lower right-hand side. And I do want to give a quick heads up. There is free training coming next week for Neo4j. You can find out more information either on that Meetup Twitch page that I linked on the last slide, or this Meetup group here that I've linked above. It is happening next week, so September 14th through 17th, which is Monday through Thursday, and it's all morning hours for me, which should work out to somewhere around this time for you guys next week. All sessions are hands-on, so you'll get hands-on experience and walking through all of how to code, and there's lots of different topics there, intro, all on Neo4j Aura, which I'm giving. There's one on the Bloom for visualization, there's one on GraphQL, and there's one on knowledge graphs. They're each 2 hours, they're all completely free, so feel free to check those out if you're interested, and hopefully we will see you there. Again, my contact information is there in the lower right-hand side. And with that, we will go ahead and turn it over to questions. But I am also going to see as well if that query finished. It's not. Oh no, I must have written something totally wrong. Okay, I'll run that again, and then I will take a look at some questions here.
Yeah. So I've got some questions here compiled for you, which came in privately to me, Jennifer. So I think there's one on certifications that you've already answered, so I'll skip right past that to the second question, okay, which is on like in the relational database world. This is from Harish. So he asks if in the relational database world we have the normalization and the first normal form and things like that. Do we have any sort of guidelines in the graph world that are similar to how you should create your databases and run your queries and things like that?
Yep, very good question. The answer is, which Neo4j likes to tease about this too, is it depends. So there are some constraints that you can put in order to kind of help keep your data clean and kind of in the right format that you're looking for. But the one nice thing, and this was kind of an aha moment for me, I came from a SQL relational background, and coming over to Neo4j, is that you are not tied to a hard data model. So you have the flexibility. You don't set up your schema beforehand. And if you try to insert something that doesn't perfectly match that schema, it just completely tosses it out in the relational world. Where in Neo4j, if you have some constraints defined, it'll help you say, hey, this data doesn't match what you've defined as being constraints. You need to fix that. But most of the time, it kind of errs on the side of allowing you to push that data in and just look at it. So this is super helpful for changing business needs. Anytime you need to go in and make a change to your data model, anytime you need to just throw some data in and check it out, you are not limited to a very strict schema that you've defined. So there are some things to kind of create some boundaries and make sure the data that's coming in is clean. Of course, there are tons of different database roles that you can give users to allow certain people to insert and not other people. So that kind of helps maintain data cleanliness and good data forms as well. But you are not tied to a schema. On the form of normalization, there are some things you can do. If you look at the data imports that I did for this data set, actually, one of the things is called merge instead of create. So we did a create statement when we talked about Cypher. There is a merge statement that basically checks the database first to say, does this entity exist in the database already? If it does, then I'm not going to insert it. I'll just either update it or just return the already found node, depending on what you specify. So there's good kind of query practices to go about where you don't get extra data being tossed in there that you don't want. But again, Neo4j kind of tends to err on the side of flexibility to allow you to do things and to move fast and keep adjusting and adapting to business needs, and then go back and kind of refactor and fix things if needed later.
Got it. And I've got like lots of other questions, and I would sort of encourage people to reach out to you directly. But one question I would want to do it now is around a structured structured but a uniform querying language. So we've seen demos of Cypher, and it looked very, very expressive. Is Cypher going to become the standard unified language for any other graph database, or is it just a proprietary Neo4j standard that we have as of now?
So there are actually several vendors who support Cypher, the most recent one being AWS. So I don't know if it was AWS, I think it was just AWS, will now support some Cypher functionality as well. We have a version of that is open source called OpenCypher, and that has been implemented by a lot of different people and a lot of different vendors. But you still have probably a handful of graph query languages out there. There's Oracle's PGQL, and there's Gremlin, and there's Cypher, and I think there's one or two others out there as well. So what's actually being formed right now is there's a group and a board of people coming together to basically create a graph query language standard, just like you have for SQL. And it's called GQL. I think there's a little bit of kind of PR and information out there on that. So if you just type in GQL, graph query language or something like that, something should come up about that. But it's got all of your major players. Neo4j is on the board for that, as well as I believe like Neptune and from AWS and some others, Oracle and other big players there as well, that are trying to come together and form a standard graph query language for everyone. And it's going to be kind of built. I know there's some things being adapted from Cypher, but there's also some things being adapted from other graph query languages out there too.
All right. So thanks a lot, Jennifer, for your time. It was a great session. And I particularly loved the demos around Cypher and the coding walkthroughs and everything. And I would really encourage everybody here to sort of sign up for those training sessions in the next week.
Yeah.
So any closing remarks? Yeah.
I just want to say a big thank you, Jennifer. It was such an insightful session, really engaging. Thank you so much for spending this time and effort to go through this with us. We will be in touch. We'd love to do more sessions with you. As you mentioned, time is too short. There's still so much more to learn. So we'd love to bring you back. And, all the best. Thank you so much once again.
Yes, thank you. And thank you so much for having me.
Bye.
Bye. Thanks, everyone.